All right, so here we go. Linear functions and their graphs. So sort of continuing on along the same line that we started on that lesson I posted last week. I've got to share my screen. I haven't done that yet. Sorry. You people at home, I'm doing that now. Share. Whoops. Too much stuff. All right. Linear functions and their graphs. Here's exactly what we're going to look at. Use intercepts to graphs or intercepts to graph a linear equation or to graph a line. We're going to talk about slope. We're going to calculate slope. And then we're going to use slope in the y-intercept to graph a line. Then we're going to look at horizontal and vertical lines. And we're going to look at slope as a vertical or rate of change, which is in a application type problem. And then use slope and y-intercept to model data. All right, so there are different ways when we have an equation of a line, and we're talking about lines on a graph here. They're going to be straight drawings, okay? One way you can write that equation. How do I pause this? Yeah, answer it. I'm trying to figure out how to pause this.
Hello. Who? Say it one more time. Azari?
Azari is not up here, so.
Nah, she ain't here. Not in the classroom.
Yeah, we don't know. Tell her I don't know where she is.
Say that again. Nah, that ain't Code Rivers. That's somebody look way better than him.
Just.
Yes. Marshawn. I'm good. How are you? Nah, she ain't here. Nah. Alright.
They want to talk to me?
Nah, she don't want to talk to you.
Who was it?
I don't know who she was.
You know, they was just looking.
But she said she come in the classroom and call back.
Okay.
If that makes sense.
Okay.
Yeah, I got her name.
But I don't know who to call. All right. So we have equations to lines. We've discussed in the previous one that now there's going to be an x term and a y variable, x variable, y variable within the equation. And there's different ways to write the equation. There's standard form, slope-intercept form, point-slope form are the three main ways we're going to look at it. Standard form is when you have the term with the x and the term with the y on the left side of the equal sign, and then the number on the right side. Now that number could be zero. Zero is still a number. So if you move x and y to the left and there's nothing left, that means there's a zero there. All right. And this is called a linear equation in two variables because there's going to be two variables within the equation until we look at horizontal and vertical lines. So all lines, equations of all lines will have an x in it and a y unless they are horizontal or vertical. We'll talk about those a little bit later. All right. To locate the x-intercept, set y equal to 0. To locate the y-intercept, set x equal to 0. So what they're talking about right there, x and y-intercept, if I have can I change color? If I have the coordinate axis there, and then I have a line like that right there, well, what they mean by the x and the y-intercept is the point at which the graph or the line crosses the x and the y axis. So right here. This is the y-axis. This is the x-axis. So this point right here where that line crosses over the y-axis is called the y-intercept. And what is true about all y-intercepts is that the x-coordinate of that point is 0. That could be at 2, 0. That could be at 3, 0. Anywhere, any point on that y-axis has an x-coordinate of 0, right? Because it hasn't moved left or right any off of that axis. The x-intercept would be this point down here where it is crossing the x-axis. What is it true about all x-intercepts? Is that the y-coordinate of that point is always 0. So if we have an equation and if we plug 0 in for x, that means we're going to be able to find where the y-intercept is. If we plug 0 in for y, we're going to be able to find where the x-intercept is. And that's the whole basis of what they're talking about here.
Reg,
Yes, sir.
I got a question.
What you got?
What type of math is it?
Bridge math.
Bridge, like I someone wants to help me and they ask, what type of math? Wait, like what type of math is it? What I take it back? Bridge math.
Bridge. I mean, that's the name of the class, but bridge math is just a review of algebra 1, algebra 2, and geometry.
So which one do I say?
You can say algebra. Just tell them algebra, and you'd be good. Anybody can do algebra can do all this. Okay, so they want us to graph this by using the x and y intercepts. They want to know. Now, in order to graph a line on a graph like that, you just need to know 2 points on the line, right? If you have 2 random points, you can put a ruler next to those 2 and draw a straight line. So you only need to know 2 points. Well, they want us to find the x and the y intercept. So what we just said, if I want to find where this line crosses this y-axis, what we said was x is equal to 0. The x coordinate is going to be 0. So if it was this point, it would be what? 0, 1. This would be 0, 2, 0, 3, and so on. So what I would do to find where it crosses the y-axis is I would go to the equation, and where x is, whoa, I put the wrong thing. Where x is, so I'm going to have 3. I'm going to plug in a 0 for x. Then everything else is going to be the same. Then what I do is I solve that equation for y. So 3 times 0 is 0, plus 2y equals 6. Well, that 0 plus 2y is just 2y. Notice what happens. When I plug 0 for x, that term basically disappears. So the shortcut to finding the y-intercept is you could just eliminate the x term or hide it with your finger. 2y equals 6, I would now divide by 2, and I would get y equals 3. That means this line intersects the y-axis at 3, right there. That point would be 0, 3. Yes, sir.
At the top, the 3, how do you get the 0 beside the 3? That's just the x right there?
Well, they wanted us to graph it by finding the x and the y-intercept. So to find where it crosses the y-axis, I put 0 in for x. So that's what I did. See where x was, now I put a 0.
So if they ask the same thing for the x, you do the same for the y?
Absolutely. That's what we're going to do next. To find the x-intercept, I'm going to plug in 0 for y. So I would have 3x plus 2 times 0 equals 6. Notice what happens. That becomes 3x plus 0 equals 6, which is basically just 3x equals 6. So when I'm wanting to find the x-intercept, I can basically just drop out the y term. Because when I plug in 0, that's essentially what happens. So when I have 3x equals 6, I divide by 3, and I get x equals 2. So if I go to 2 on the x-axis, that's the x-intercept. That point would be 2, 0. Then to draw the line, let's see if there's a line on here. Yep, right there. I just basically put a line connecting those 2 dots, and I have now graphed that line using the x and y intercept. Now, this is an easy way to graph a line. It's easiest when it is in that standard form where the X and the Y are on one side, right? But the problem comes if the x-intercept and the y-intercept are the point 0, 0. Notice if I have this line that goes through the center, that is both the x-intercept and the y-intercept. So I don't know how that line is going to, what angle it's going to go on because it's only going in one point. So there does have to be another way we graph lines, although most lines can be graphed by graphing the x and y intercept. Okay? Now, let's move on. Let's see. All right. Now, next thing we're going to talk about is slope of a line. This is going to help us graph lines in other ways. Why is this not going? There we go. Whoa. All right. Slope of a line. There's the definition. Slope of a line through the points x1, y1, x2, y2 is the change in y over the change in x, the rise over the run, y2 minus y1 over x2 minus x1. Generally, what slope is it's how steep the line is. Like if you were walking up a hill, the steeper the hill, the more slope it has. The flatter the hill, the less slope it has. Okay? And notice how that line, if we go across the page like we're reading from left to right, that line is going uphill. Well, it's going to have a positive slope. And the steeper it is, the bigger the slope will be. Well, lines that go downhill always have a negative slope. Okay? And the steeper it goes downhill, the bigger negative slope it's going to have. Now, the way we find the slope is we find 2 points on the line and we say, okay, how much did that line change vertically? It's changing y up and down divided by how much it changed left and right. It's horizontal change or it's change in x. You also hear it a lot, the rise over the run. Rise, or it could be a fall. If it's a negative line, it would fall, but the rise is just talking about vertical movement over how many units you have to go to get to the side to get to the next point. And the formula, if you have 2 points, is you subtract the 2 y coordinates and divide that by the subtraction of the 2 x coordinates. That's how you find the change in the 2 y's, is subtract them. Okay? All right. Let me move on to the next one. Okay, so there's a couple ways we can find slope. One is if we have a picture, we can actually count out the slope. All right? So what you do is you indicate 2 points that you know are on the line. And in this case, we have indicated these 2 right here. Then what you do is you start on the leftmost point. This is the easiest way to do it. Start on the leftmost point and you count either up or down till you get even with the other point on the line. So to get even with this point over here, if I start here, I go down 1, 2 units. So that's my numerator. Down is negative, up is positive. So my numerator is -2. Over, and then I count how many spots it takes me to get over there. 1, 2, 3, 4, 5, 6, 7, 8. -2 over 8 is the slope of that line. Now, we do need to reduce it as a fraction. These little calculators we have in class, you can put in the fraction -2 over 8, hit enter, and it will reduce it for you. This reduces to -1/4. Okay? So that's how you can count out the slope. Another way I could have found this slope is I could have labeled these 2 points. This point is 1, 2, 3, -3, 3. And this point is 1, 2, 3, 4, 5, 5 comma 1. Now, if I use the slope formula there, what I do in M, all right, now why does M stand for slope? I looked it up. It's like goes back to some Greek word or Latin word or something that meant some kind of slope or something. But just know throughout this chapter, when we talk about M, we're talking about the slope of the line, how steep it is. All right. And you start with one point and you move towards the other point and you subtract. I subtract the y coordinates. So 3 minus 1. And then -3. I subtract the x's. The subtraction of the y's goes on top. The subtraction of the x's goes on bottom. Notice, in this case, I get 2 over -8. That reduces to -1/4. All right, and it doesn't matter which way you subtract. If I had started down here and subtracted the other direction, notice I would have gotten 1 minus 3 and 5 minus -3. Well, 1 minus 3 is -2, minus a -3 is plus a positive, that's over 8. It's still -2 over 8, which is -1/4. Okay, what you have to be careful of is I don't subtract the y's in one direction and then turn around and subtract the x's in the other direction. That will cause me to miss my sign. So I got to subtract the y's in the same direction as I subtract the x's. Okay, so make sure you do that.
You mean like 3 minus 1?
Yeah, if I go 3 minus 1, then I have to take and go -3 minus 5. I can't go back the other direction. I have to go the same direction for both of them when I'm subtracting. All right? Okay.
So you just pretty much find the slope.
Yep, that's what I'm going to do. This is what I'm going to do here. Now there's no picture. All right? So now we're going to find the slope. We just have 2 points. So what we have to do is sometimes I like to just say, okay, this is x1, this is y1, this is x2, and this is y2, but you don't have to take your time and label those if you don't want. And the formula is y2 minus y1 over x2 minus x1. So what we're going to have, 4 minus -1. Now, if you have trouble with adding and subtracting with positive negatives, use your calculator. All right? It's there for you to use. And then x, that's going to be -2 minus -3. Minus a negative is always plus a positive. So I end up with 5 over 1, and that simplifies to 5. So the slope of that line is 5. All right? So slope is just a matter of subtracting 2 numbers and simplifying a fraction, which those calculators will do that stuff for you. All right, same thing right here. Goes through the points -2, 4, and 7, 6. So I'm not gonna label them this time. I'm just gonna make sure I go the same direction. I say 4 minus 6. I subtract the y's. So that means I have to now start with -2 on the x's. Minus 7. 4 minus 6 over -2 minus 7. That is -2 over -9, which simplifies to 2/9. It's okay to have a fraction for a slope. The slope is 2/9. All right, let's move on. Moving on up. All right, now here's our second way to write the equation of a line. All right, the first way was standard. We put the x and the y on both sides, left side of the equal sign, and it made it easy to graph by x and y intercepts because we could just cover up the x term or we could just cover up the y term. But really the easiest way to graph all lines or most lines is this form, what is called the slope-intercept form of the equation. All right. And here it is, y equals mx plus b. The y is the same y. That's the variable that's got to be in these. And that x is the same variable we have in those. M, there's the slope. So that tells me the slope of the line right there. That number in front of x says that's the slope. And then the new thing here is the b, which is the y-intercept. Right? We talked about that at first. That's where that line is going to cross the y-axis. Okay? Now notice, to put an equation in slope-intercept form, we solve it and get y by itself. So once we have y by itself, then that's slope-intercept form. Another thing that's helpful about the y or the slope-intercept form is these graphing calculators, which we have access to these in here too. It has to be in slope-intercept form and for you to graph it on that calculator. So if we want help from our calculator on graphing, we have to get the y by itself. Okay? All right, so there are two equations in slope-intercept form. Y equals 2x minus 4. So what I know about that line is it crosses the y-axis at -4, and the slope is 2. Okay? Now, if I wanted to graph that line real quick, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. The way I would graph that line is I start with the y-intercept. So I know it crosses that y-axis at -4. So I'm going to go down to -4 on the y-axis. Remember, I have to have 2 points. That's 1 point. Then I'm going to use the slope. I know the next point, or there is going to be a point to the right of this that goes through the slope 2 over 1. So 2, it's just 2, but I put that over the understood 1. That means, remember, the top number is what I go up or down. Positive is up, negative is down. And the bottom number is how far I go to the right. So if I put my pencil on the dot I just put on there, I would go up 2 over 1. Okay? That's the second point. Now I've got 2 points, so I can draw a line through that. So there's the equation or the graph of that line. Let's look at this one. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. All right, this one, it tells me the y-intercept is +2. I go up to the y-axis at +2. And then the slope is the number in front of the x. It tells me I'm going to go +1 up over 2. +1 up to the right 2, 1 over 2. So from this point, I would go up 1 over 2. And there we go. There's that line. Okay? So making an equation into slope-intercept form makes it very easy to graph, because the number that's trailing along tells me 1 point, and then I can use the slope to find the second point. So here we go again, same thing. Y equals 2/3 x plus 2. It's in slope-intercept form. So to graph it, I graph first the y-intercept of +2, so I go up to +2. And then my slope is +2 over 3. Up 2, right 3. Up 2, right 3. Right there. And I draw that line. There's that graph. All right, now, if you notice, this one is not set in slope-intercept form. This does not have y by itself. So what we have to do is we have to put it into slope-intercept form. All right, and it's just like solving an equation. We want to get y by itself. That means we want to get the x to the other side. So what I would do is subtract 2x from both sides, and I would have 5y equals negative 2x plus 0. And then 5y is multiplied by 5, so I would divide by 5. And I want to take and divide each single one of these numbers by 5. So what I end up with is y equals, that won't simplify, so that's negative 2/5 x, and then plus 0 over 5 is 0. Now it's ready to graph. It's in slope-intercept form. The y-intercept is 0. The slope is negative 2 over 5. Down 2, right 5 from that point. So I'd go down 2, right 5, and then I can draw my line through those points. All right. All right. Now we're going to look at horizontal and vertical lines. I'm going to skip over that. All right. Notice the equation of this horizontal line. Y equals negative 4. Notice there is not an x. So if we have an equation that does not have an x, it's just y equals some number, that is a horizontal line. Notice this is a line that goes through the y-axis at negative 4. So the variable that's there tells you what axis it crosses through. That's how I always remember that y equals negative 4 is horizontal, because it crosses through the axis at negative 4. This is negative 4 right here. Here's negative 4. So I know that's going to be a horizontal line that crosses through that. All right. If it were x equal 5, well, there's no y term. This is a vertical line. And it tells me where it crosses through the x-axis. It crosses through the x-axis at 5. Here's 5. All right, notice a horizontal line there would cross through all the x-axis. We just need it to cross over the x-axis, so this means it has to be vertical. So it's going to be this line right here that I didn't draw very straight. But that's it. The vertical line going through that. There it is. X equals 2 is the vertical line that goes through the x-axis at 2. All right. So that's the two special cases where it doesn't have both an x and a y. All right. One other thing, the slope. Horizontal lines have a slope of 0. Vertical lines do not have a slope at all, because if we use the slope formula, it would cause the denominator to be 0. Since we're subtracting, the x coordinates are the same, it would cause the denominator to be 0. So vertical lines have no slope. Horizontal lines have a slope of 0. Okay, so that's something you need to remember about horizontal and vertical. All right, so here's just sort of an application type problem that deals with slope. All right, whenever you get into a problem like a real world problem, a lot of times they call it rate of change. Basically, a graph represents, if it's a line graph that's going up or down, that's representing how something is changing over time. How fast is it changing is the slope. If it's real steep, it's changing really fast. Its rate of change is large, just like the slope is larger. All right. So here's the problem at hand here. The graph shows the percentage of American men and women ages 20 to 24 who were married from 1970 through 2010. Find the slope of the line segment representing women. So the first thing we got to do, which one is the women? That's this top blue one. And notice they essentially give us, 2 points on this line. Now, it doesn't matter what it is, if it's years, months, whatever, we can find the slope given 2 points. We subtract the y's for the top, we subtract the x's for the bottom, right? So in this case, the slope is going to be 65 minus 21, that's the 2 y coordinates, over 1970 minus 2010. Now, one thing to note, this line is going downhill. So I need to know that I'm going to get a negative answer. That way, if I get a positive one, I know I've messed up. It's going downhill, so it has to be negative. So I'm just going to put all this in my calculator at once. I'm going to call up a fraction, and I'm going to put 65 minus 21 on top, and I'm going to put 1970 minus 2010 on bottom. And my slope is negative 11 over 10. Now, sometimes when we have an application problem like this, the fraction doesn't make as much sense. All right. So what is the slope telling us? Well, the left line is the percentage of women that are married, that were married, ages 20 to 24, and the bottom is the year. Notice in 1970, there were a lot more women married at that age than there were in 2010. It's dropping quickly. So that means every year, fewer and fewer women that age are getting married. Okay, well, the slope tells us by how much is that shrinking every year. Well, negative 11 over 10 doesn't tell us a whole lot in this application problem. So a lot of times they want you to change it to a decimal. So if I change that to a decimal, 11 divided by 10, that is 1.1. And it is a percent per year. So that makes a little more sense. It is saying that the negative just tells us it's shrinking, it's getting smaller and smaller, but it tells us that there's about 1.1% fewer women every year that are the age of 20 to 24 that's getting married. All right. So generally, and the men are dropping too. Generally, it's just saying people are usually waiting longer to get married, probably is what this means. For the most part, there may be some people that decide they're not, maybe there's fewer people getting married altogether too. I don't know. But the point is being able to pick out the 2 points, find the slope, and then apply the slope. That's what we were looking at. All right. Should be getting pretty close to the end. This is just going to show you how to do it like I just did. Yep, that's it. So I will activate 5.2. And I'm going to stop sharing my screen because we are done with that. Now I've got to figure out how to end the video. I have to flip it around here. I don't need that. There we go. Oh, there it is.